So for example, 6.28, I'm not going to make you do this with a table or with the formula. I'm going to let us use technology. Somewhat because really I believe that technology is the appropriate way to work through a statistics course like this. But also there are 12 customers and that's going to be a lot of work for us to calculate all of this. So this example, we know that 60% of all computers sold by this large computer retailer are laptops and 40% are desktops. So we just have these two outcomes and we have the type of computer purchased by each of the next 12 customers is recorded. And we're going to assume that these customers are making their choices independently. And so our random variable is going to be the number of laptops sold among the 12. So our success here is going to need to be the sale of a laptop. So that's a probability of 0.6. And the number of trials here is going to be for the 12 customers. So if we want to know the probability that exactly 4 computers are laptops, that's what we want to find. Probability that x equals 4. So we're not doing the formula this time. We're going to StatCrunch. So StatCrunch has a lot of calculators built into its system. And so if you go to Stat, Calculator, Binomial, then we can either do the standard where you can have your number of trials, and in this case we have 12, and then our probability of success, in this case is 0.6, and then we can either do less than or equal to, greater than or equal to, less than, greater than or equal. So remember, this is a discrete random variable, and with discrete random variables, it does make a difference if it's equal to, less than, greater than, less than, or equal to. Like all of these are going to give you different results. So we want the equal to, and we want exactly 4. So 12 trials, probability of success, and x equals 4. You hit compute, and there is our answer. And again, I usually use 4 decimal places, so 0.0420. Now, what's the probability that between 4 and 7 are laptops? We are doing the inclusive case, so that's going to be less than or equal to for both of these. Now, this is the probability that x equals 4, and the probability that x equals 5, 6, and 7. But since we're using technology, we don't have to do all 4 of those. So let's go over to StatCrunch, and we can choose the between. And so it's going to keep our 12 trials and our probability of success. And here you have the lower value and the upper value. Now, there is one thing that I need to warn you. The between option on StatCrunch only lets you do less than or equal to. If you don't want to include that number, then on the lower side, you would need to add up. So if you didn't want to include 4, you would start at 5. And if you don't want to include the upper value, you would subtract. And so if you didn't want to include 7, you would start at 6. So if you're not going to include the endpoints, that's how you would do it. But most of the time, you're going to include the endpoints, which is why StatCrunch has it defaulting to this, because this is how you would need the question answered 99% of the time. So hit compute, and there's our probability, 0.5466. It's so much easier using technology. Now we can also look at example 6.29, and here we have a survey of 505 American women that in 2016 indicated that they favored, 25% of them favored preserving the tradition of having the bride promise to obey her husband as part of wedding vows. So suppose that exactly 25% of American women favor preserving this tradition for all American women. So we're extending this 25% based on this sample. So it may not be exactly 25, but that's what we're going to do for the purpose of this problem. And if we considered a random sample of just 20 American women, then how many women in that group would favor preserving the promise to obey? So we can think of this as a binomial distribution. They would be independent trials. There are 20 trials. The probability of success is 0.25. So if we wanted to know the probability that exactly 5 of the 20 women favor this tradition, then we're looking for the probability that x equals 5. So let's go to StatCrunch to do this. We need to change our number of trials to 20 and our probability of success to 0.25. And we also need to change to standard because I want exactly 5. So everything looks good. So we hit equal and we get 0.2023. And notice here they are creating this little histogram for us with these probabilities. And we'll be thinking of something kind of like this in one of the later chapters. What's the probability that 10 or more favor the tradition? So here, the only thing that you have to decide is if you put the little bar underneath your inequality sign. So do we include 10? It's 10 or more, so yes, we include 10. So we're looking for greater than or equal to 10. Some of the questions in your homework, you do need to pay attention. Less than means that you would not include that number, so you would not have the little bar. Less than or equal to, then you would put the little equal to. No more than, that's a tricky one. No more than is less than or equal to, because you don't want any more than a particular value. And at most is that same thing. But anyway, for this problem, we want 10 or more favoring the tradition. And so here we change x to be greater than, and we make that 10. Now, we would not want to do this by hand, because this would be 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. That's a lot of things to calculate. But we can do this very quickly with our calculator here. The probability that 10 or more women in this group would favor this vow is very small, 0.0138. So we'll do 0.0134. You're not going to have more than half of a sample of 20 women favoring this vow most of the time. 99% of the time, you would not get a sample where half or more favored this vow. So that's how you can put this kind of thing in context.